Hello, hello. Another day, another problem. Not in the very positive messages here. Okay. Today, what we have is a situation where we have a mass that goes down, falls down into like a whatever, like a surface that is 45, that has an angle of 45 degrees, and it has a completely a completely elastic bounce, like collision, and so it falls down and bounces off completely horizontally here, whoop, until it reaches the ground. And again, what we want to find today is the distance s. We can add a few things. Well, we always have our happy gravity. Oh, and the velocity right before it reaches the surface is the same as the velocity right after it bounces off of it. So we have a happy velocity. Well, yeah, then we have the unit vectors. Whoop. This is so not horizontal. Bear with me. Okay. So, what do we start with? We start with our happy equations. I will call them always like motions, equation motions. Should I look it up? I should look it up. Yeah, they're the motion equations. Okay. Whoop. And then we have, oh yeah, here we have the time equals 0, the initial time, and here we have the final time. Then we have h plus, okay, we can write this, 0t minus gt squared over 2, minus g because gravity is negative. Now, we know that here the motion in the y direction is horizontal, so the angle is equal to 0, theta is equal to 0, and we know that sin 0 is equal to 0. So this doesn't exist. Nice. And this is one part. Then we go to the next one, which is as usual x big T is equal to s, y big T is equal to 0, because we are on the ground. Then we use s big T to find t, which is equal to s over v. This, by the way, can only be used with constant velocity, like when the velocity is constant. And it is because gravity is only on the y-axis. So on the y-axis, it's not constant. I don't know where to look. It's not constant, because we have acceleration, but on the x-axis it is. And so we can use this. And so, we can plug it in here, like on the y formula, because if I'm not wrong, the time is equal for both for the x and for the y. And so, technically, you can't use the equation for constant velocity when the velocity is not constant, but since it's 1 for one, it's 1 for the other two. I think so. So, yeah. So we have that h minus g s squared 2v squared is equal to 0. and then we just solve for s. So foop, 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 2 squared h over g, right? We put this here, and then we divide by g. Okay, it's equal to this, to s squared, and so s is equal to 2 squared h over g. Very close, but now we have to find v. Okay, well, yeah, which is equal to 2hg times v, because we just remove, if it's squared, and if you take the square root of something squared, you just take the value, the absolute value. So, first part done, now we look for v. And I will do it in another color. So v, what do we do? We have two parts in this question. We have this one, which is free fall, and then we have the Castrol's parabolic, is it called? Yeah. Ask me the math or like the calculations, the words, just the process, but I think it's, yeah, the parabolic. Yeah, so we can use different types of energies. The kinetic energy here in the beginning is 0. Why? Because it's not moving. While the potential energy is mgh, because this is like okay. Then, and this is here, like we're like at the time of the collision, right before, we have that the kinetic energy now is there, is present, because the ball is moving, and it's mv0 squared over 2, while the gravitational, the potential energy is mgd, because this is the height after the collision. Now, this is a closed system, nothing, the energy, as we know, nothing is created, nothing is destroyed, so it must mean that mgh is equal to mv0 squared over 2 plus mgd. Now we can remove the m's, they happily cancel out, and then we will just solve for v. So yeah, okay, write everything down. Mg is equal to v0 over 2 plus gd, and then we go forward, whoop, 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 and so whoop, 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 whoop. We can do this, or we can just because g is in both places, so 2g h minus d is equal to v0 squared, and so we can write this. And so now we have found v, and so now we can plug it in here. So we have 2, no, I just wrote it down, yeah. Foop, 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 times v, so times 2g h minus d, and so we cancel things out, or like we simplify it. everything, because actually, yeah, like also during exams, it's good to write all of the steps, because stress or just tiredness or whatever, you don't write something, you will get less of a point. But if you write all of your logic, then the professors will kind of understand, or like will probably give you some more points because of the logic and stuff, instead of just giving a full answer. So we have 2 times 2 h. Oh damn, I made a mistake. This h should be this distance. I'll move on. I'll keep on writing, and then let's troubleshoot together, shall we? This is right. This comes from here. No, then it's from here. So this is the mistake. So because this is right, this is wrong. I deleted what was here. What did we have? Well, anyways, this should be this distance, because we're calculating just from here, like from after the collision, and yeah, because before that there was no x direction whatsoever. I think that's why. So yeah. So this is I mean, it's still the height, but just another height. What? Okay. So this becomes, oh, this is a black. This becomes 4, and so we have, well, which is equal to d h minus t. And this is equal to s. If you stay for a bit longer, we can also find what's the height that d should be, so that s can be the longest. Do you get what I mean? So what's the optimal height of d, so of the collision, of the elastic collision, in order to have the biggest distance. Good job for deleting what I needed. Wait, hold on. What did we have? It was s was equal to 2 d h minus d. Okay. I trust myself on this. Okay, so what do? We find, so, yeah, just explain it. We find the derivative. Why? Because we want to find like a maximum. We want to find this point. And thus, we use the derivative. And so we have ds, dd of this, which we can write as like this. And so we use the conjugate rule, I think it's called. So first we take what's outside, which is 2 times 1 second, foop, foop, and then 1 second minus 1. And then inside, we just keep what's inside, h minus t, times what's inside, which is, we can rewrite this to hd minus d squared. So we treat the d as an x, and so it becomes h minus 2d, and so we have h minus 2d, and so we can rewrite it a second to make it pretty. So we have 1, hold on, okay, 1 d h minus d minus 1 second times h minus 2d. So we have d h minus d, h minus 2d. We set it to 0 because it's not growing, because when we have the maximum or a minimum, but in this case it's a maximum, we set equal to 0. So it will be h minus 2d is equal to 0, and which becomes h equals to 2d, which becomes d is equal to h over 2, which is the optimal height for the collision to happen, for the mass to land the furthest away as possible. Peace.